Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. In this session, I am going to solve JEE Main PYQ. Let us see the question number 8. So, in the question number 8, what is asked? Two vessels A and B are connected via stopcock, through stopcock. So, there are two vessels here, it is already shown. So, this is one vessel B and this is another one A. Both are connected by a stopcock. Stopcock means which allows the gases and which can also stop the flow of gases. That's called as a stopcock. You can close and open. In the question, it is given that the vessel A is filled with gas. It is containing gas. Okay. In the question, it is not mentioned that what is containing in B at a certain pressure. The entire setup, this setup is kept in water. In this water, it is kept. It is immersed in water. You are seeing here in the diagram. And is allowed to come to thermal equilibrium with water. So now, after immersing into water, the total setup temperature is constant. After opening the stopcock, so it is allowed, after opening the stopcock, the gas from vessel A expands into vessel B. So what is there in the B, he did not mention, but in the question it is mentioned that after opening this, the gas present in vessel A has moved into vessel B. And there is no change in the temperature. This is very important. So some process happened here. In this process, there is no change in the temperature. Delta T is equal to 0 or dt is equal to 0. dt is equal to 0. Right? According to first law of thermodynamics, we know that delta U is equal to Q plus W. He is mentioning that delta T is equal to 0. Same temperature. So 0 is equal to Q plus W. That means Q is equal to minus W or minus W is equal to minus Q is equal to W. Okay. Here some process has occurred. That means work is done. A has expanded. That means work is done by the gas. When work is done, then there should be change in the heat. When there is change in the heat, there should be change in the Q. That means heat. When there is change in the heat, temperature must change. In the question it is given that temperature is not changing. Temperature is not changing. See, work is done. Work is done. So dW is equal to, he is mentioning that temperature delta T is not changing, but work is being done. Okay, if work is done, delta T must not change. That means there is one possibility, and that possibility is work is not equal to 0. If some work was being done, then there must be change in the heat. If there is change in the heat, the temperature must change. Okay, the temperature is not changing means there is no change in Q. That means dQ is equal to 0. dQ is equal to 0. dt is equal to 0. Then dW will also be equal to 0. So du is also equal to 0. So it is confirmed that work is not done. Work is not done represent that there is one possibility, and that possibility is free expansion. What is that? Free expansion. What is meant by free expansion? Expansion of gas against vacuum. That means there is no external pressure. Work done is equal to minus P external into delta V. When external pressure is equal to 0, 0 into, there is change in the volume. A is expanding into B. So delta V, that is equal to 0. So there is only one possibility, that external pressure must be equal to 0. If external pressure is equal to 0, that initially there must not be any gas in the vessel B. So that is option given. The pressure in the vessel B before opening the stopcock is 0. So what is that meaning? The meaning is that there is no gas in the vessel B. No gas represents that it is vacuum, there is nothing. Okay, so that is only the possibility. Next, question number 9. 1 mole of an ideal gas expands isothermally. Number of moles is equal to 1. And he has mentioned that that is a isothermal process. Isothermal expansion. Isothermal process or expansion means, okay, delta T is equal to 0. If delta T is equal to 0, delta U will also be equal to 0. Delta U is equal to 0 because delta U is equal to NCV delta T. According to first law of thermodynamics, we know that delta U is equal to Q plus W. This is 0. 0 is equal to Q plus W. Then Q will be equal to minus W, or minus Q is equal to W. So if you calculate work done, then heat can be calculated. And the question asked is isothermal and reversible process. Isothermal reversible process. And here it is given expansion. Why expansion we are speaking? Initial volume is equal to 10 decimeter cube and final volume is equal to 20 decimeter cube. See, initial volume 10 decimeter cube, final volume 20 decimeter cube at a constant temperature of 300 Kelvin. So volume is increasing. That means it is expansion. And we have derived a formula to calculate the work done. W is equal to minus 2.3. Here log 10 is 2.3 given. So we have to take only 2.3. We cannot take 2.303. nRT log V final by V initial. And that is equal to minus 2.3 into 1 into, what is the R value given? R value given is 8.3 joule per Kelvin per mole, and temperature given is 300 Kelvin into log V final is 20 decimeter cube, V initial is 10 decimeter cube. Then what answer will you get? You have to multiply this. So 2.3 into 1 into 8.3 into 300 log 2. What is that? Log 2. So log 2 is given as, in the question it is already given, log 2 is equal to 0.3. So 0.3. So if we calculate this, what you will have the answer? What answer you will get? Minus 1720.341. Answer will be in joules. Answer is in joules, right? If you want to convert into kilojoules, then minus 1720.341 into 10 power minus 3 kilojoules. Approximately what you get? Minus 1.7. calculating, you get 1.72 or 18 approximately. Okay, 2 approximately kilojoules. So work done is minus 1.72, and we know that work done is equal to Q is equal to, so you want to calculate Q is equal to minus W. So Q is equal to minus of minus 1.72, and that is equal to plus 1.72 kilojoules, right? Understood? So question asked is, first one is delta U. Delta U must be 0. So 0. And Q. So it is 1.78. It is not 1.78. It is 1.718. 1.718. This is also minus 1.718. Wrongly typed. Okay. So the answer will be this. Okay. Because first asked is delta U, then Q will be positive, work done is negative. Okay, delta U 0. So this will be the option, right? Next, coming to next question, question number 10, right? Question number 10, a liquid when kept inside a thermally insulated closed. Let us take a thermally insulated liquid. So this is liquid. Okay, so it is insulated, right? Insulated, that means there Q is equal to 0. Many times we have spoken about that. Is mechanically stirred from outside. So through some spoon, like spoon, you are stirring it. What will be the correct option for the following thermodynamic parameters? Okay, when you are stirring, there is some work done. Liquid is not doing work. The spoon is doing work on that liquid. That means work is done on the system. Work is done on the system. So from first law of thermodynamics, we know that delta U is equal to Q plus W. Q is equal to 0. Then delta U is equal to, so work done is positive, delta U is also positive. That means work done positive means work is done on the system. So delta U positive, work done positive, Q 0. So where is that? Positive means delta U greater than 0. Q is equal to 0. Greater than 0 means positive, no? So work done is also greater than 0, right? So this will be the answer. Next, coming to question number 11. Speaking about question number 11, so let us see question number 11, this one, right? What is that question number 11 given? Arrange the following in the order of magnitude of work done by the system or on the system at constant temperature. Reversible expansion, irreversible expansion, right? So let us see expansion. First of all, let us see expansion. So expansion, reversible and irreversible. Irreversible. Reversible expansion. Reversible expansion. We know that work done is equal to V1 to V2 minus P external into dV. Okay, this is what. When you are going with a reversible process, we know that P external is equal to P internal minus dP. Okay, P external is equal to P internal minus dP. That means internal pressure is slightly, infinitely greater. dP means infinite small amount of pressure. Infinite small amount of pressure. Understood? So that means P external is almost equal to P internal here. Right? So for example, let us consider. This is the case. P internal is slightly greater. Let us take this one, 760 is P external. P internal must be 761. How much? Just 761. 761. What is that? mm is P internal. Okay. P internal will be almost same. Okay. Coming to irreversible process, work done is equal to same V1 to V2 minus P external into dV. Okay. So P external is equal to P internal minus delta P. Here you see delta P. That means P external is smaller than P internal. Irreversible process. For example, let us take P internal is 760. Let us take it as 760. Same 760, 760. But P external is very much less than that of P internal. That means P external might be something like 750. Okay. Now we know that work done is given by formula minus P external into dV into dV. Okay. So more the external pressure, more the work done. More the external pressure, more the work done. So where is external pressure more? Where is external pressure more? In a reversible process, you are finding external pressure more. So work done, reversible process, reversible work done in expansion, in work done in reversible process is greater than work done in irreversible process. Understood? This is in the case of what? In the case of expansion. In the case of expansion. Let us see in the case of compression. In the case of compression. So in the case of compression, again, okay. So let us see here compression. Again, compression means external is greater than internal. So P external is equal to P internal plus dP. This is in the case of a reversible process. This is in the case of irreversible, let us say. Reversible and irreversible. So let us take P internal, P external is equal to internal, same, let us take. Okay. So P external is right. 760. P internal is something like 759. 759. Okay. So P external, as it is reversible process, this dP is very small. P external will be almost equal to P internal, right? So 760 is almost near, very much near. And coming to irreversible, irreversible means process occurs in finite steps, you cannot reverse. So P external is equal to P internal plus delta P here. That means let it be 759 P internal, but P external will be not 760, it will be something like 770. Okay. So again, work done, we know that work done formula is equal to minus P external into dV. Okay. So more the external pressure, more the work done. Here, in which case external pressure is more? In the case of irreversible process. So work done in irreversible process is greater than work done in reversible process in the case of compression. In the case of compression. So it is opposite. Whereas in the case of expansion, reversible is greater than irreversible, whereas in the case of compression, irreversible greater than reversible. Okay. So if you represent in the terms of a graph, let us draw graph for this. Okay. For example, here let us draw graph. This is what PV graph. So what is this? Initial. If you draw arrow like this, so this is what? V1, V initial, this is V final, right? So this will be reversible expansion. Reversible expansion. If you draw a graph for reversible compression, in this, you will get the same type of graph, but opposite arrow. PV. Again, initial volume, V initial, V final. So what is the work done? Work done is the area under the graph. Which graph? PV graph. Both areas are same. This is again reversible compression. That means work done in reversible expansion is equal to work done in reversible compression. Okay. So these two are same. When you draw graph for PV graph for irreversible expansion, that means internal pressure is more, external pressure is less. So external pressure, when external pressure is less. This will be the graph. V initial, V final. V initial, V final. Okay, this will be the area under the graph. Coming to PV graph, irreversible compression. Compression means P external must be more. P external more. More means so more here up to here. So let us go with initial volume. This is initial volume. This is final volume, right? So this will be the area under the graph. So if you look into these based on the options, irreversible compression is having more area under the graph, right? So from the options provided to you, if you see irreversible, work done in irreversible compression in single stage, single step, happening in a single step. So D will be greater than, see if you see area under the graph also, you can find D greater than, so these two, that means reversible process. Least will be irreversible expansion. Okay, so from the explanation you can find that D greater than C, these two are reversible. C and A are reversible, these two same. Least is irreversible expansion, so the answer will be second option. Okay, so you understood. Next, coming to next question. Next question is numerical value question. The magnitude of work done by a gas that undergoes a reversible expansion along the path ABC. Reversible expansion. So let us see the graph, this graph. What is asked? The question asked is magnitude of work done by the gas. Magnitude of work done by the gas. Why we are mentioning that it is by the gas? Because what is here initial volume is 2. Initial volume is 2. Initial pressure is also 2 at this point. Right? Here at a pressure of 8, it has undergone a process from A to B. And after that it has undergone a process from B to C. At B it will be 8. So overall this is initial volume, this is final volume. Volume has been increased. Volume is increased. When volume is increased, then we say that it is expansion. Expansion work is negative actually. Okay. So in the question, in what units the question is asked? Simply he has asked the magnitude of work done by the gas. He did not ask it in any units. So PV graph, this is pressure and this is volume. The area under PV graph is the work done. So area of PV graph is equal to work done. So if you calculate the area, we calculate this area. So let us take ABC, 8 is D, here starting is E, let us take. Right? So total area is equal to area of square, let us take square, ABDE plus area of triangle, okay, BDC. Then what do you get? Area of triangle ABDE, right? This is equal to ABDE. So 8 minus 2, here is also 8 minus 2. 8 minus 2, this difference, 8 minus 2 is 6. This is 6 and this is also 6, right? 8 minus 2. This is not 0. If it is 0, it will be 8, right? So 6 into 6. What is this? 6 Pascal, right? What is this? Let us see. 6 Pascal into 6 meter cube. 6 meter cube plus area of triangle half into height into length. So this triangle. 12 minus 8, 4. Here B2, this one. This is 6 again. Pascal into meter cube. 6 6 36 plus 2 times cancel. 2 6 12. That is equal to 48 Pascal into meter cube. So the answer is 48. Okay. So understood. Next question. So what is this question? This is one is 12. Speaking about question number 13. The heat of combustion of ethanol into carbon dioxide and water is minus 327 kilocalories at constant pressure. So enthalpy of combustion is given, heat of combustion or enthalpy of combustion is equal to minus 327 kilocalories is given. The heat evolved in calories at constant volume. At constant volume means, okay, so this is also at constant volume means what you get, delta U you need to calculate. The heat evolved in calories at constant volume at 20, if all the gases behave ideally. So this is asked. So heat of combustion of ethanol. Ethanol is C2H5OH, which is in liquid state. It is combustion means O2 gives CO2 plus H2O. H2O is in liquid. Carbon dioxide is in gas. Oxygen is in gas. Then what do you get? You need to balance the reaction. C2. So 2 CO2. 5 plus 1 6, so 3 H2O, 2 2s 4, 4 plus 3 7. 7 means you have 3.5, right? 2 carbons. See oxygens if you see 3 plus 4 7, 7 plus 1 8 are there, right? So balance it clearly. O2, right? Already 1 is there. Here 7, so 3. That is sufficient. So 3 2 6 1 7, 2 2 4 plus 3 7. Right? It is balanced. Now you want to calculate delta Ng. Delta Ng means number of moles of gaseous products minus number of moles of gaseous reactants. Gaseous products are 2 minus number of moles of gaseous reactants are 3, that is minus 1. So we want to calculate delta U, delta H is equal to, right? We have a formula relating delta H and delta U. What is that formula? Delta H is equal to delta U plus delta N RT. Then what you want? Delta U is equal to delta H minus delta N RT. That is equal to delta H given as minus 327 kilocalories minus delta N is minus 1 into R value given in the question is R value 2 calories per mole per Kelvin. So 2 into 10 power minus 3 because here we are calculating in kilocalories, right? Then temperature is equal to, what is temperature given? 27 degrees centigrade, then that is equal to 300 Kelvin. So if you calculate this complete, then what you are getting is, right, delta U is equal to 326,400 calories. First we get kilocalories, then you have to convert it into, right, calories, because minus into minus gives you plus, so something will be minus here, this is minus, this is plus, then you will get a less amount, and that is equal to, so heat evolved at constant volume, this is heat evolved at constant volume, right? That's the answer. So asked in what units? In calorie, heat evolved. Delta U is equal to what you are getting? Minus value. This minus represents that it is evolved. So simply heat evolved at constant volume is 326,400 calories. Hope so you understood. Okay. Next question is 14. The internal energy change in joules. Internal energy change is delta U is asked. And 90 grams of water undergoes, 90 grams of water means 5 moles of water, 5 into 18 gives you 90. So liquid water undergoes complete evaporation, so 5 moles of gas at 100 degrees centigrade, right? Enthalpy of evaporation is given, so let us take delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants, that is equal to 5 minus, here it is gas but here it is liquid, that is equal to 5. Okay, so delta H given, delta H of evaporation 41 kilojoule per mole, but here it is 5 moles. Okay, you know that delta H is equal to delta U plus delta nRT. Delta H is 41 kilojoule into 5. Why you are multiplying with 5? Because the question asked is for 5 moles, but in the question it is given delta H for only for 1 mole. So kilojoule is equal to then delta U plus delta N is 5 into R value given 8.314. Okay, so 8.314 into 10 power minus 3 we are using. Why you are using? Here we have taken kilojoules, right? So that's the reason why you are using 10 power minus 3, so that it will be in kilojoule. Okay, next temperature given is 100 degrees centigrade, that means 373 Kelvin. So delta U, so when you calculate delta U, what you get is 189,494 point, right? What answer you are getting? 189,494.39 joule. So this is nearly equal to 189,494 joule. So this will be the answer. Okay. Question number 14. Next, coming to question number 15. Question number 15. See question number 15. Speaking about question number 15. 5 moles of an ideal gas number of moles is equal to 5 isothermal expansion. What is this? This is isothermal expansion, right? Expanded isothermally from initial pressure P initial is equal to 2.1 megapascals and P final is equal to 1.3 megapascal. That means initial pressure is more and final pressure is less. So it is expansion process. Against P external pressure is given as 4.3 megapascal. The heat transferred in the process. So Q is asked. As it is isothermal process, delta U is equal to 0. From first law of thermodynamics, delta U is equal to Q plus W. 0 is equal to Q plus W. So Q is equal to minus W. So if you can calculate work done, then we can get Q. So we know formula isothermal expansion. Okay. Work done is equal to constant external pressure is given. That means minus P external into V final minus V initial. So here they are mentioning that ideal gas and final volume and initial volume are not given. Okay. As it is ideal gas, we can go with ideal gas equation PV is equal to nRT. And V is equal to nRT by P. So instead of volume, you can use nRT by P. So work done is equal to minus minus P external into, instead of V final, I can write N R T2 by P2, right? So T2, is it necessary to mention T2? No, because the reaction is happening at constant temperature. So temperature remains constant. Minus nR T by P1. So pressure is changing. Temperature is remaining same. Then what you can write, W is equal to minus P external into nRT 1 minus P final minus 1 by P initial. Okay. So then what do you get? Minus P external given. So 4.3 into number of moles given 5. R value in the question given R value 8.314. Right? 4.3 into 8.314 into temperature given 293 Kelvin. 293 constant temperature into 1 by P final is 1.3 minus 1 by 2.1. So this is the data, right? Then work done, what answer you will get? So final answer is, your work done answer is, you will get it as minus 15347.7 joule. If you want to convert it into kilojoule, then work done, want it to convert into kilojoule, then work done will be equal to minus 15347.7 into 10 power minus 3 kilojoule. Why we are converting into kilojoule? Okay, because the question asked is in kilojoules and it is asked per mole. We have calculated it for 5 moles. Okay, right? So Q is equal to minus W. that is equal to plus 15.3. Okay, 15.3, right, kilojoule, 15.35, right? But this is for 5 moles. But the question asked is for per mole. That means you have to divide the plus 15.3 by 5. So 3 approximately per 1 mole. This is 3 kilojoules. So the answer will be 3. Okay. Coming to next question, question number 16, right? Question number 16. At 25 degrees centigrade, 50 gram of iron reacts with HCl to form FeCl2. The evolved hydrogen gas expands against a constant pressure of 1 bar. The work done by the gas during the expansion is. Here, what is taken in the cylinder? Fe and HCl are taken. Fe plus 2 HCl gives rise to FeCl2 plus H2. So 1 mole of iron is producing 1 mole of hydrogen gas. Okay. So number of moles of iron is equal to given weight by molecular weight. That is equal to given weight is 50 grams in the question. Say 50 grams. And molecular weight is 55.85. Then what will be the number of moles you get? And multiplying, you get it as 0.8952. So how many moles of hydrogen gas is released? The same number, because 1 mole of iron is producing 1 mole of hydrogen, right? Now so what is the question asked? The question asked is the evolved hydrogen gas expands against a constant pressure of 1 bar. Constant pressure of 1 bar. The work done by the gas during this expansion. Okay. Then work done is asked. In the case of work done, formula is work done is equal to minus P external into delta V. As this hydrogen gas considered to be ideal gas, we can apply PV is equal to nRT. V is equal to nRT by P. Okay. So we have number of moles, but we don't have so directly P into V is equal to nRT. So that can also be as W is equal to P into V. P into V is equal to nRT. So minus, okay, you can take nRT. Right? So minus number of moles 0.8952 into R value given in the question 8.314 into, okay, Then temperature given as how much? 298 Kelvin, 25 degrees centigrade. That means 298 Kelvin. So answer. So what answer you are getting? You see minus 2218 joules. So the answer will be 2218 joules. Magnitude of work done. You have to take only magnitude of the work done, right? So that is question number 16. Next, coming to question number 17, let us take. The standard enthalpies of formation of Al2O3 and CaO are given for the reaction. The standard enthalpy of the reaction. So let us see here. The reaction is 3CaO plus 2Al gives rise to 3Ca plus Al2O3, right? Enthalpies are given. When enthalpies are given and enthalpy of reaction is asked, standard enthalpy of reaction is equal to sum of the enthalpies of formation of products minus sum of the enthalpies of formation of reactant. Okay, so that is equal to product calcium is given. So enthalpy of formation of an element in its standard state is taken as 0. So 3 into enthalpy of formation of calcium. Calcium is 0. Okay. Enthalpy of formation of an element in its standard state is considered to be 0. Plus aluminum Al2O3, how much given? Al2O3 is minus 1675 kilojoules. Okay. Next, minus of enthalpy of formation of reactants. Reactants 3 moles into CaO, how much given? Minus 635. Minus 635. Okay. Plus 2 into this is element in its standard state. Element is in its standard state. So when element is in its standard state, more stable state, then its enthalpy of formation is considered to be 0. Then you will get minus 1675 minus into minus plus 3 into 635. Then what answer do we get? So the answer is answer is 230 kilojoules. So that's the answer. Okay. So next question is 17, 18. Let us see 18th question. Question number 18. Question number 18. System is there. It's a very easy question. First law of thermodynamics. It is a system does 200 joules of work. Work is done by the system. So work done is equal to minus 200 joules. And at the same time absorbs 150 joules of heat. It is absorbing Q is equal to, okay, plus 150. So what is the change in the internal energy? But it is asked mode of delta heat, magnitude only magnitude. It is equal to W plus Q, that is equal to work done is minus 200 plus and Q is how much? 150, that is equal to minus 50. But mode is asked, mode of delta U will be mode of delta U, only magnitude is asked, that is equal to 50 joules. So the answer here will be 50, right? Next question is 19. Question number 19. Question number 90. Let us see. In the question number 19, what is asked? What is asked? Question number 19. For water at 100 degrees centigrade and 1 bar, water at 100 degrees centigrade and 1 bar, delta vaporization H minus delta vaporization U. Delta H minus delta U is asked. Delta H minus delta U. Okay. So water liquid is converted into water gas. Okay. So delta N will be equal to number of moles of gaseous products minus number of moles of gaseous reactants, 1 minus 0. Why it is 0? It is in liquid state. It is in gaseous state. That is equal to 1. So delta H minus delta U is equal to delta nRT. That is equal to delta N is 1. R value given, okay, 8.31 into, right, and the temperature given, temperature is at 100 degrees centigrade, 373 Kelvin. So then what answer do we get on multiplying this? Okay, what is the answer? Answer is 3099.63 joule per mole, because 1 mole only, no, right? So then that is equal to 30. You can write as 30.99 into 10 power minus 2. So the question asked is in 10 power minus 2. That is equal to 31 into 10 power minus 2. So the answer will be 31. Right? Answer will be 31. Coming to question number 20. Question number 20 is also similar to that of question number 19. Delta H is given. Assuming that water vapor of an ideal gas occupies much larger volume than liquid, the internal energy change for this evaporation. Okay. So for water molecule converting into H2O gas, okay, delta N is equal to 1 minus 0 is equal to 1 again. You are asked delta H is equal to delta U plus delta nRT. What is asked question? Assuming that water vapor of ideal gas that occupies much larger than the internal energy change. So delta U is equal to delta H minus delta nRT. Delta H is given as how much? 41 kilojoule per 1 mole minus delta N is 1 into R value given 8.3 into 10 power minus 3, because we have taken here kilojoule, into temperature is 373 Kelvin given in the question. Okay, so then what you get? You get answer 41 minus something gives you here 38 kilojoule per mole, right? So the answer will be 38. So that is with this session. I expect everyone following the procedure for solving the questions of JEE main. Hoping so everyone is understanding Thank you for watching up to end of the video. If you like, share and subscribe the channel, so that and click on the bell icon, so that you will receive notifications for the new videos which I upload. Thank you very much. We shall meet in the next session, right?